Creating a wall power adapter for the CN-160 lighting kit. Today on Mikey's Lab. Hi, and welcome back to the lab. If this is your first time joining us, go ahead and click that subscribe button down below to stay up to date on all the science, engineering, technology, making, DIY, and now Mini Myth Mondays that we produce every single week. Today in the lab, we're looking at a new set of lights that we purchased, which are lighting me right now, the CN-160s. The only issue that I have with these, they're great lights, they're very cost effective, there will be a review coming shortly, is that there's no way to power them from the wall. They only use battery power. However, conveniently, they came with these adapters that are designed to allow you to use a different camera's battery to power it. So we're going to hack them. Here's what we know so far. The batteries that are in these lights are 2-cell lithium-ion batteries, which means they have a nominal voltage of 7.4 volts, a fully charged voltage of 8.4 volts, and a considered dead voltage of approximately 6.4 volts. So we're going to want to feed around the 7.4 volt mark. We also know that every LED draws about 20 milliamps of power, and we know that each light has 160 LEDs in there. So if we feed 2.5 amps to 3 amps, we should be well within the right range. Now, I've watched a lot of other videos of people building this particular mod, and I'm kind of disturbed by what they're telling people to do. One of the videos has somebody feeding these lights 12 volts with a 1 amp maximum. While I have no doubt that there's a power regulator inside of these lights, they're obviously made for a maximum of 8.4. So at the very least, you're going to decrease the lifespan of your light by following these other tutorials. So I figured I would post one online of the modifications that I'm doing to this, what I'm using to make sure it is safe, and how we proceed from there. So what we're going to do is we're going to drop down to the bench. This is going to be a very quick one-day build on our series. Let's see how you can take a device that's designed to run on a 2-cell in-series LiPo or lithium-ion battery and replace it with wall current. So here we are at the bench. So to do this modification, what we're going to need is a voltage regulator. Again, this is a standard $2 voltage regulator. I will leave a link in the description to where you can buy them. Usually you buy them in like sets of 5 or 10 because they're really dirt cheap. We're going to need a JST connector because this is what I'm going to put on the end of the 12 volt power supply that we're going to feed this. You need the battery adapter tray that came with your CN-160 lights. You need some scraps of wire, some solder, some wire strippers, obviously a soldering iron, and we're going to investigate before we do a whole lot, so we're going to use the screwdriver. Okay, so right off the bat, I don't know if you can see it or not, but there are 2 pins right here. And earlier, I did some exploration to find out that they are connected to these pins right here. So literally, this seems like it's a passive adapter. If we take one of the actual batteries for the camera, and we look at the bottom, I don't know how much detail you can see right now, but this is the positive side, that's the negative side. So if we translate that across, it means that this pin has to be positive. Again, if we just flip this over and look at it like this, negative, negative, positive, positive. So positive has to be away from me. So we know that we can just apply the ground here and 7.4 volts here. But I want to see if there's a better way to work with this. I've noticed that there are 4 screws on the bottom. Let's start by taking a look. Again, we may wind up just soldering to those 2 external pins on the outside, but a favorite channel of mine, as he always says, don't turn it on, take it apart. And we definitely confirmed that this entire thing is just passive. There's absolutely nothing active inside of this adapter. So what I'm going to do is put this back together. Get both plates together again. So at this point we know that there's nothing inside of this device, that it's all 100% passive, right? And it's just metal plates that make the contact. So we're gonna go ahead and screw this adapter back together. And we're gonna get ready to start making some modifications. And we have physically confirmed that the side of the pin on the top versus the side of the pin on the bottom are electrically connected. In fact, it's the only thing inside of this that is connected in any way. Alright, so now we know essentially what we're going to be doing here. I'm going to take our little power adapter here. I'm going to tin the pads, make it easier to work with, make soldering better. Those are the 2 input pads. We'll flip this around. Quickly tin the output pads. Okay. Alright. We have the JST connector. We're choosing this end so that the power end is always protected. If I just swing my 12 volt power source, my ATX power support extension here, breakout board thing. I don't even know what to call this, to be honest, but it's very handy. I have 12 volts right here. You always want the source voltage to be the female, so that you don't have live pins just flying everywhere. So this is going to be on the input side. Red is obviously positive. So let's just go ahead. Solder this in place, like so. Then like so. And many of you who have been to our channel before have seen me use these devices. And you know that the power output is adjustable. So I'm going to change my screwdriver bit to be a flathead, so that I can adjust the power output from this. Okay, so we have the flathead bit inside of the screwdriver at this point. Okay, first thing I want to do is hook up the power into this regulator to make sure that I didn't do something wrong. To verify that it doesn't start on fire right away, grab our multimeter. I'm going to try to position it so you can see the screen. It's obviously set to voltage DC. Check the probes. It's set to 5.2 volts. Obviously I was using this for USB power of some type. We obviously want the 7.4 volts of a phenomenal 2-cell battery pack. We're just going to grab the screw here. On these things, clockwise usually goes up, but don't assume that ever. Especially ones that have come from, say, the Far East. So we are going to supply the lights with 7.4 volts. This is assuming each cell at a nominal charge of 3.7 volts will put out 3.7 volts, put them together, 7.4. That is the safe voltage for these lights, not the 12 volts that I've seen other people use, which at best is just going to shorten the lifespan of the light itself. At worst is possibly going to start a fire if it's not meant to dissipate that much heat. Alright, so now we've got the inside of these things to solder to. This is not going to be the easiest soldering job in the world, but I'm going to try to tin these right here. Alright, so both of those are tinned. Awesome. So now I'm going to take the battery pack that we know. Verify once again this is ground on the left hand side here. So we're just going to go ahead. I am going to trim this wire to be as short as possible. Okay. Okay, that's on there pretty good. Do the same with the positive wire. Actually, it's already pretty much as short as it's possibly going to get. So we're going to go ahead and kind of flash solder that on there. Yeah, I don't know how well you can see this, but I have the two wires soldered there perfectly. Those are going to electrically connect to this plate and this plate. If we flip this over, we see positive, red, negative, black. It seems perfect for what we want. Okay. So I'm going to go ahead and, because we don't want this very long, I'm just going to shorten those two wires a lot. You're going to need to cross for this particular adapter, because as you can see, output plus is over here and output minus is over there. We're going to go ahead and just gingerly pull these up. We don't want to work this wire too much or it's just going to break. But just need to strip this a little bit, like so. And we're just going to put this in place. Grab the soldering iron. See if I can get this a better view for you. We're going to hold that essentially right where it's going to go. Like so. And we're going to do the same with the positive wire, which is right here like so. Okay. That should be all we need to the soldering iron. I'm going to go ahead and pause the video for a second while I get the hot glue gun powered up. Alright, so the hot glue gun is powering up. I'm just going to use it to insulate all of this, make it so that the wires don't move, and give some strain relief to the entire system, which is a critical step that, again, they seem to have just missed in the other videos that I watched. I don't know what was going on with those, but this is a very simple hack, I understand. I just wanted to show you how to do it properly and safely. And just while we're waiting for the hot glue gun to power up, I'm just going to verify that I get the same voltages and same polarity from our new wall power pack as I do from a charged battery for these particular lights. So there's the positive, there's the negative. We see 8.2. This is a fairly charged battery. Turn this on. And you can see that we get 7.4 volts out, which again is nominal for this pack, and that the polarity is right. Excellent. Turn this off again while we're working with it. How's that hot glue going? Okay, we got some hot gluage. So the first thing we're going to do is insulate the crap out of both these contacts. You insulate them and provide strain relief for the wires. So when they get pulled on, they don't get pulled on the actual connection. I'm also going to add some hot glue on top of these actual connections. And a little down the side, only to help keep the regulator in place. A little more down this side, again, really to keep the regulator board in place. And then we're going to put some over top of the input connections as well, mainly to function as strain relief for those. Alright. It's not the prettiest device in the world, but it's safe. It's not going to overvolt your light. It'll give you a chance to give more than enough current for your lights, and should keep them running on AC power for a little while. So what we're going to do now is I'm going to grab one of these lights. You're going to notice that the light in the video changes, and we're going to see if it powers it. Alright, I am sorry about the crappy lighting, but I just lost half my light, so let's see if our modifications work. And there we have it. 12 volt input from the wall, coming into the LED light, being regulated down to 7.2 volts, and we have a working LED light that we can now power with wall current. Damn, these lights are bright. Alright. So there you have it. What I'm calling a one-day build, really a 5-minute kind of hack that takes these awesome lights and addresses the one downfall that they have. And that's that they cannot be powered from the wall. We also took a look and came up with a circuit that's going to be safe for the lights. Some of the others that are out there I want you to be very careful of. If you're going to shove 12 volts at these, again, the best that you're going to do is overpower these lights, and you're going to burn them out quicker, so they're just not going to last that long. At worst, you're going to burn down your house because you're going to be causing these lights to dissipate that extra voltage that it's not really designed to dissipate. So I don't know how much thermal protection is inside of these lights. Yeah. Use a voltage regulator. Feed it 7.4 volts that it's expecting with a lot more than a single amp. And everything should be golden. If you like this video, hit the thumbs up. If you don't like this video, tell me why in the comments down below. Right, don't forget to share, and most importantly, subscribe to keep yourself up to date on all the news from the lab. Once again, thank you for joining me in the lab, and I will see you next time.